Hi class, today we're going to be talking about section 9.1, which will cover translations. Now previously we had worked on an activity where we experimented with different types of transformations, and today we're going to focus on this type called translations. So before we get started into seeing this in action, we're going to do some vocab. Your first word is isometry or rigid motion. This means that you have a transformation in which the image and pre-image are congruent. That's what a rigid motion is. Think about it in terms of that word, rigid and motion. You're moving the shape, you're changing it in some way, but the sides and angles are not changing, it's staying rigid. Now we have talked about what congruent means in previous classes. It means to be the same. So when shapes are congruent, when an image and a pre-image are congruent, it means that the shape has changed in no way in terms of size. So if you take a look at my picture, all of the angles match all of the angles, and all of the sides match all of the sides. Nothing about size has changed here at all. That's what a rigid motion does. If you transform a shape and the size changes, then we call that something different. Then we have translation or slide, and that's our big word for today. A translation is an isometry where all points are moved the same direction and distance. All the points, which means when I move all the points in the same way, the shape does not change its size, it just shows up in a new location. So you see this puzzle piece here is a good description of what's happening here. This is the same puzzle piece. Same size, same design, same everything. The only difference is that they moved it to a new location. All right, next let's talk about our key concept. So for our key concept, we're going to go further into translations again. That definition is that it maps all the points of a figure the same distance in the same direction. So take a look at this image we have here. We have triangle ABC, and then we have another triangle here, ABC. Now these triangles look the exact same, but this one's just moved over to the right a little bit. What you should notice though is look at how these letters are named. Notice how they're no longer just A, just B. We have these little dash marks. Those are called primes. I call this A prime, B prime, C prime. And we use those dashes to help us compare points such as B and B prime to show that they're similar. They came from the same location B. But you can agree when I say these are not in the same place, so they have to be named slightly differently. Okay? Now this is what's going to be really important for your notes and for your examples today. This is the notation we use for when I want to translate something. They're never going to tell you to move it up or down or left or right. They're going to have it written like this, which means that you have to be able to decipher what's in here. So let's break this down. First you have the letter T. T is for translate. So when you see that T, that's telling you you're going to be doing a translation. Every time you see these rules written out for your transformations, it's going to start out with a letter for that transformation. So translation goes with T. For rotation and reflection, you'll have R. For dilation, you'll have D. Okay, so that first part, T, means that you're going to be doing some translating there. Okay, then you have the X and the Y. Now this is really important, and this is probably the most important thing of that rule. That X there tells you to move horizontally. The Y number tells you how to move vertically. Now if you forgot, horizontal is your side to side movement, vertical is your up and down movement. Now the reason why X is horizontal and Y is vertical is because of your graph. On your graphs, we have our X and Y axis. This is my X-axis, This is my y-axis. So these numbers are telling me how far over to go for x and how far over to go for y. This is telling you your direction, and it's going to tell you how far to go in that direction. Okay, now what's left here? Inside the parentheses, I'm going to have the shape that I'm changing. This is your pre-image. And what it equals is going to be your end result, your image. You can think about this in terms of function notation. When you saw f of x equals 5 in Algebra 1, this is their way of telling you that I'm doing function f to this value, and it gives me this answer. So here, you're doing this transformation to this triangle to give you this result. Same idea. All right, we're now going to start getting into some examples. So as I go through these examples, guys, please feel free to pause and test yourself. Try to do the question on your own first, and then play to see if you can get the answer correct. Also pause if you need to write down something or if I go too fast. So the first question says, does the transformation below appear to be a rigid motion? Explain. So so go ahead and try to answer that on your own. But a recap, rigid motion means that the shape moved, changed in some way, but the size remains the same. So on problem A, we're looking for, do these look like they're the same image? They do. So our answer would be yes, because they are congruent or the same. But on problem B, you can look at these. Looking at that size, they are definitely not the same. So my answer here is no. They are not congruent or not the same, not the same size. Moving on to problem 2. In the diagram, triangle A prime, B prime, C prime is an image of triangle ABC after a translation. So they ask, what is the image of angle A and B? And what are the pairs of corresponding sides? Now what you just have to recognize here is, what are they asking me to answer here? You're going to see this word corresponding a lot within this unit. Corresponding means matching. So when they're asking what are the images of A and B, they're saying, here's A. This is my pre-image. What does it turn into? What matches that angle on my new shape? Now that should be pretty easy to say that point A matches point A prime. Okay, one, because visually you can tell that it was just moved down, so these match. But secondly, they have the same letter. A and A prime match because they have the same letter A. So when they ask you, what does A prime, what is the image of that? Sorry, what is the image of angle A? Your answer is going to be A prime. And for angle B, again, what does B match? What does that point match? Over here, it matches B prime. So if I'm looking at angle B, my corresponding angle is going to be angle B prime. Okay, now same idea for corresponding sides. Okay, they're asking you the same thing. Is, if I start with the side over here, what does it turn into over here? Only difference is they're not going to give you the sides ahead of time. They want to know what are the pairs. What matches what? So first thing we should do is figure out what are my 3 sides of my original triangle. If you look over here, I have side AB, which is a segment, side BC, which is a segment, and side AC, which is a segment. Those are the 3 different sides of my shapes. I'm getting those names by just naming the points that connect to make that side. Now, to name what corresponds to that, we're going to do the same thing we did in problem A. What matches A? What matches B? So what side matches AB? You should see pretty easily that that's going to be my A prime B prime as a segment. For BC, B will match B prime, C will match C prime, so the segment will be B prime, C prime. And lastly, for AC, that's going to match A prime, C prime as a segment. Okay, all of this is just getting you into the idea that certain things match when I translate, reflect, rotate them. Now what you should know about this is that all of these images, all of these corresponding parts are equal to each other because translation doesn't change size. So you can write it like this, as I've shown here, or you can write it as an equation such as this, to show that these are equal because they are. All right, let's go ahead and move on to the back side. We're now going to start getting into those really big math-heavy questions for translations. When I told you guys when we were working on our activity the other day, we said that it was not our expectation, it was not our goal to become mathematicians where we were experts on transformations. Today we're going to start actually getting into that mode of being more experts on this type of material. So on question 3, they're going to start off by asking, what are the vertices of T, -3, 4 of triangle RST? So we're going to take triangle RST and we're going to do this transformation to it, graph the image, and name the vertices. Okay, so let's first figure out, let's look at this and figure out what is that telling me to do. The T means to translate, as we discussed before. Now the numbers tell me in which way. The first number is my X, and the second number is my Y. If you ever forget that, just keep in mind that it's alphabetical, just like your regular coordinates. So if the X movement is -3, that means I'm going to be moving horizontally -3. Now which direction is negative? This one. So that -3 tells me to move left 3. While that 4, that's a +4 for the Y, which means I'm going to be going up because up is positive. Up 4. So this is the main gist of what we're doing when I'm transforming this. Okay, I'm going to be moving it left 3 and up 4. So let's go ahead and take that and apply it. Now you can do this by just taking each individual point and moving it in this way. So I'm going to take R. Notice my scale, okay, it's counting by 2s. So I'm going to go over 1, 2, 3, and then up 1, 2, 3, 4. So R is going to go there, and I'm going to name that R prime. I'm going to take point S. I'm going to do the same thing. Left 3. 1, 2, 3. Up 4. 1, 2, 3, 4. It's going to show up right there. And lastly, T is going to be left 3. 1, 2, 3. Up 4. 1, 2, 3, 4. Right there as T prime. Now if I connect these lines, you should notice that, hey, these look like the exact same shape, and they should. If you moved all the points correctly, it should look the exact same. Let's go ahead and write down our new points real quick because they did ask for that. R prime is now at -2, 6. S prime is at +1, 5. And T prime is at -1, +1. Now a lot of you guys will choose to do this type of transformation to figure out what it's telling you in directions. Follow the directions physically on here. Okay, but as another method, if you don't like that, you can get this same result using some simple addition. Okay, again, x is -3. I'm subtracting 3. Y is +4, so that's like adding 4. Now let's take this point t. T is currently at 2, -4. If I subtract 3 from the x, 2 minus 3 is what? -1. And then if I add 4 to the y, -4 plus 4, oh sorry, this is at -3. -3 plus 4 is 1. Take another point. This is at 4, 1. 4 minus 3 is 1. 1 plus 4 is 5. So without graphing anything, without doing that side-to-side motion, you can still find the answer by adding or subtracting, but I know a lot of you guys would prefer to just do this. All right, next, problem 4. What is a rule that describes the translation that maps ABC to A prime, B prime, C prime? Now this is a typo on the notes, guys, so go ahead and cross those out, and let's change that to LMN and L prime, M prime, N prime, because that's what's pictured here. We want to make sure we have the right triangles written. So what we're doing in problem 4 is the reverse of what we just did in problem 3. We have the transformation. We want to write the rule. So we are translating, so we're going to need a T. We need to figure out what are the x and y I'm translating. And I'm going to do that transformation to triangle LMN. So this is just the basis of what I need. I'm translating in some way to this triangle. So let's go ahead and let's take a look at our image and figure out what's happening. Now the best way to do this, the easiest way probably to do this, is to kind of do what we did in the last one with counting how much I go over, counting how much I go up or down. Start off with any point. You can choose either L, N, or M. I'm going to choose M. M's right here. This is the pre-image. I want to get it all the way up here to M prime. And I need to figure out how I get over there. So I know I'm going to go to the right. And then I'm going to go up. Let's figure out how much I go right and how much I go up. Keep in mind, again, this counts by 2s. So I'm going to go 1, 2, 3, 4, 5, 6. I went right 6. Then I go up 1, 2, 3. Up 3. Now you're just going to take these numbers and put it in here in the right spot. Right 6 is x going +6. So +6 comes on my x spot, and then up 3 is going to be positive on my y. So the 3 goes here. And that's my answer. What I would say to be careful on is that if you're writing it like I did here with right, left, up, down, make sure that you, 1, put the numbers in the right spot. Don't flip-flop these. And second, make sure you have the correct positive versus negative number. All right, guys, last question. Carmen leaves her apartment and travels 2 blocks east and 5 blocks north to the library. She then travels 4 blocks west and 1 block south to the grocery store. Where is Carmen in relation to her apartment? So this is a composition of translations here. She's moving, but she's doing several moves here. She starts off by going east and north to the library, and then she goes again and travels west and south to the grocery store. So this is like 2 transformations here. So think about what happens if I go east and then I go west. What happens when I directionally go that way? What happens if I go north and then south? What happens there? you should be thinking that some of those directions will cancel out on each other. So there's a couple ways you can think about this, okay? You can think about it in terms of comparison. I have 2 blocks east, 5 blocks north. Now 4 blocks west, never eat soggy worms. West is the opposite of east, so 4 blocks west. Okay, and then north and south are opposite, so 1 block south. Now take a look at what's happening here. If I go 2 blocks east and 4 blocks west, that's like going over 2 units here and then going 4 units back. You still have 2 west blocks left over, so that's a net gain of 2 blocks west. Same thing for north and south. If I go up 5 blocks north and then go 1 block back south, that's going to be a net gain of 4 blocks north. And that's where she ends up being located in relation to her apartment. There's different ways to solve this. You can draw a graph, you can draw a picture. I had some people drawing vectors. So the first one is 2 east is positive 2, 5 north is positive 5, and then 4 blocks west is negative 4, 1 block south is negative 1, and then just adding. But that will give you the same result here. Okay, and some people really like that because it's much more visual. So that was all of our notes, guys. Please feel free to go back and rewind at any point if you feel like you need some extra assistance. I will be back in class tomorrow to go over this with you guys. For now, if there's time left over, I want you guys to go ahead and get started on your 9-1 packets. The first page, front and back, is your translations. So go ahead and work on what you can, skip what you can't do today, and work on the front page, front and back. Don't go on to reflections yet. Do not do that. That's going to be for a later lesson. But when you're ready, go ahead and start on your packet. All right, thanks, guys.